Hello, good evening, everyone. Just to discuss one question here. This question is coming from linear programming, applicable to ACCA performance management and or CIMA or CF Sri Lanka or any other relevant examination. Let's go through the question. A company makes two products, R and S, within three departments, A, B, and C. Production times per unit, contribution per unit, and the hours available in each department are shown below. As you can see from the question screen, that product R, product S, and they gave you the contribution. Now it is sometime you may have to calculate the contribution here. They have provided you the contribution. That's so life is a bit easy. Then we have department A, B, and C. Hours per unit, 8 hours of department A to produce product R, 10 hours of department A to produce product S. Likewise, and the maximum available hours will be 11,000. That is the capacity. Same way, department B and C information given. Determine the optimum production plan and calculate the maximum contribution which can be earned. Now, in answering this question, we should follow something called linear programming. So, in doing linear programming, some aspects where we need to understand that it is a question based on constraint. And here again, please understand that constraint is, in other words, limiting factors. Now, in answering any limiting factor question, one method is using marginal costing. But for this question, we can't use marginal costing because we have more than one limiting factors. So when I have more than one limiting factors, we cannot use marginal costing. The other option is linear programming. Linear programming, there are two methods: graphical method and simplex method. The graphical, to answer any linear question with regard to limiting factor using graphical method of linear programming, it is also, you should understand that there should be only two variables. Whereas if you to use simplex method, you could have two or more variables. And now today I'm going to discuss a question based on this. So anyway, these are just some introduction. Now what we first do is that we need to identify the objective function. What is objective function here? Objective function is normally denoted in Z. Here, if you read the question there, they say that per unit, my contribution is $4 for R and $8 for S. So, what you mean by objective function? What would be the total contribution you would be generating after knowing how many units of product R and how many units of product S will be produced? So, the equation now, if I assume product R is X and product S is Y, and my equation will be then 4x plus 8y. This is my objective function. So that is the first step. This is step number 1. And after knowing this, then we need to work it out the constraints. We have three different constraints or limiting factors. Limiting factor related to department A, B, and C, and each they have given you the arrangement or relationship that the available needed hours per unit for department A, 8 hours for product R, and 10 hours of product S, but the total I have 11,000. So I need to make this into an equation. The equation for that will be this. See, I'm producing 8 hours for product R and 10 hours of product S, and I assumed each be producing X unit of R and Y unit of S. So 8X plus 10Y, and maximum available hours will be 11,000. So this is equation number 1. So second equation is, so this is department A. So the second one is department B. Same method. You can see here 4 hours of R and 10 hours of S. So what you do is you take 4 hours of R, 10 hours of R. So 4x plus 10y is equal to 9000. This is equation number 2. And then the department C. Department C will be 12 hours of R and 6 hours of S. So 12x plus 6y is equal to 12,000. This is equation number 3. And then you also need to understand that there is something called non-negativity constraint. X is greater than or equal to 0 and y is greater than or equal to 0, meaning our output will be more than 0. So that's exactly the formulas are. After knowing the formulas, we need to resolve the formula. How I resolve the formula? Using the graphical method, what we do is that we find out the solution based when x, if the x is 0, how much will be y? 11,000 divided by 10, I am getting 1100. And when y is 0, how much will be x? 11,000 divided by 8, that is 1375. Same way, department B, when x is 0, y will be 900, and when y is 0, x will be 2250. When you move on to department C, when x is 0, y will be 2000. When y is 0, x will be 1000. So, and accordingly, we work out and find out what is the highest uh, reading in each line. For x, my maximum coordinate is 2250, y 2000. So, when you sketching your diagram graph, what you have to find out what are your maximum readings. As you see in here, this one is 2000 and here it is 2250. Now we can plot the graph based on the calculation. If the x is 0, y is equal to 1100. So you can see here. So this is this number. So this one. And when the y is equal to 0, x is 2250, that we have plotted, and then I have sketched the line. I will have a straight line like this. Second one, when x is equal to 0, y is equal to 900. So you can see that is, one second. No, when x is equal to 0, y is equal to 1100. So that is this. So 1100 is this. This is 1100. And when y is equal to 0, x is equal to 1375, and that is this. That's the first diagram. That is this one. Second one, when x is equal to 0, y is equal to 900. So that is this. This is 900. And when y is equal to 0, x is equal to 2200. That is that. So that line is, so 4x plus 10y is equal to 9000. So that is the second equation. So that is this. Third one, 12x plus 6y is equal to 12,000. When x is equal to 0, y is equal to 2000. So you can see the reading is 2000 here and the reading is here 1000. So accordingly, that is 12x plus 6y is equal to 12,000. So we have sketched the diagram. Now we need to work out something called feasible region. The feasible region will be a region where every constraints are satisfied by the diagram. Now, if you can look into this area. So this will be our feasible region. So then there's a rule, there's a theory called corner point theorem. According to corner point theorem, what it says that optimum solution lies on any of the corner in the feasible region. Accordingly, so our answer should be either 1, 2, 3, 4, 5. So then in order to find out which one of these, there are five possibilities. We can't spend time checking out everything. So in order to do that, we have something called ISO contribution line. What you do is you use your objective function z is equal to 4x plus 8y, and then we come up with a hypothetical number. How you do that? You take the gradient of each two numbers, 4 plus 4 into 8, 32. So then here the reading normally here 2000 and here 2250. So just figure it out in that thousands. So multiply that by 100. So 32 into 100. I got 3200 here. So when x is equal to 0, y is 400. When y is equal to 0, x is 800. Now what you do is you draw that line. So that is this line. So then then after that you have to parallelly move up, and according to linear programming rules, optimum solution in a profit maximizing situation, you will find the answer at the furthest point in the those corners. So if you move you take a paper or something, as you try to move like this parallelly upwards, and then see where this line coincides with one of the points at last. And if you really do that, the answer will be at point 4. So point 4 will be the optimum solution, and at point 4, then we need to use some simultaneous equation to resolve the problem. So we take these two equations. How I take that two equation? Based on these two lines. One line is 4x plus 10y is equal to 9000. The other line is 8x plus 10y is equal to 11,000. Use that and then solve and find out how much is y and then how much is x. And then work out and calculate what is your maximum contribution. Answer is 7,600. So this will be the answer for this question.